Hello all, good evening. We are here to present the project about the performance testing on NG911. So this is myself, Vinay.
Hi, I'm Nishchar.
So the scope of our project is to perform the testing of the ESRP, which is Emergency Services Routing Proxy, and we use the SIP tool to track the SIP protocol. So we need to know the operation of the SIP tool, and we need to capture the various characteristics for the performance testing, and we test the call establishment rate. And the main project goal is to find the maximum registration rate that the device under test, which being the Emergency Services Routing Proxy, is capable to handle without any failures, and that we do using the SIP tool. And the major tasks and the milestones of this project were to understand the basic architecture and the call flow of NG911 summed up by the previous team. And we need to learn how to use the SIP tool so that the testing can be easily done with it. And then we had to configure the ESRP to point to the SIP server and not to the normal call flow wherein it takes the PSAP URI from the lost to database and forwards it to the appropriate PSAP server. So here we measure the maximum call rate that the ESRP can handle in this. So what is next generation 911? It's the way the public will be able to make calls in any format such as voice, text, or video, and not just the voice as in the present one through the internet protocol-based networks. And PSAPs of the future will be able to receive data from any personal devices calling 911. So what is Emergency Services Routing Proxy? It's a component which is either placed at the state level or the county level in an ESInet architecture. So it's basically a SIP-based proxy server. Based on the location, it routes the call to the appropriate PSAP. So, and the SIP performance tool is an open source performance testing tool for the SIP protocol. And here we have the two parts of it, one being the user agent client side and the other being the user agent server. So there are ways to do it, like you can use the custom XML scenario files for the client and the server, or the standard ones which are available. So our logical architecture of testbed is pretty simple. So we have a SIP client which initiates the call. We have the SIP client which initiates the call being made to the ESRP, which is being the device under test, and the ESRP forwards it to the SIP server. So our physical architecture in a college lab would look like this. We have a switch, and we have a SIP client, the ESRP, and the Wireshark, and the SIP server being connected to the switch and Wireshark to capture the traces. And we actually disconnect the ESInet hub that is not being shown. I think in the we disconnected from the ESInet hub. So the command flow is as follow, and we need to have the sudo rights for the root user, and with the command shown wherein there are multiple options, with -sn being to embed the predefined scenarios used for the client and the server, and -r being the call rate in calls per second, and -i is wherein we specify the IP addresses for the source and the destination, and -rp being the rate period, which is measured in milliseconds. So the similar command will be used at the server side with the exception that the call rate and the rate period won't be there. And so from here, Nishchal will take on with the results of the rest of the project.
So hello and good evening all. So I would explain the various test cases we performed to measure the maximum call flow when there was no device in the test, and the invites which were being successfully routed through from the client via the ESRP to the server. So first we used two test scenarios, one of which is we directly established a call between the client and the server, and we had to monitor the maximum successful call establishment rate, and we found that to be 2,200, as you can see. And at 2,300, we see the calls being dropped, and there was no successful calls being established. We can see some dead calls here down. So we had to further narrow down the gap between. So we suspected that the unsuccessful call rate be between the range 2,200 and 2,300. So we further narrowed down our algorithm to establish the, maximum, to determine the breaking point, which was found to be 2,250. And these are the observations we made. As I explained, these were the maximum successful call establishment rate when the call flows directly between the client and the server was found to be 2,300, and the unsuccessful call rate was 2,300. And the exact breaking point we found out to be was 2,250. So now we tried establishing the registration rate where the invite was successfully forwarded from the client to the server via the ESRP. And at 30 calls per second for a span of 1 minute, the invites were successfully forwarded to the server. So at 30 calls, we ran a test for 1 minute, and as you can see, there are 270 invites here. And the server side would receive all the invites at the range of 30 calls per second. So at 35, we see the dropping of invites between the client and the server, or with the device on the test. So here you can see 275 invites being forwarded by the client, but here the invites were being dropped, so at the range of 35 calls per second. So we had to further go ahead and narrow down to find and devise the exact breaking point. So this was a suspicion. So yeah, we tried at 33, and we further determined that the invites were being dropped. For instance, there were 262 invites being forwarded, and still the invites were dropped. And we tested this at 32 calls per second, and the invites were successfully forwarded to the server via the ESRP. So that was the maximum successful call rate that we observed, that the invites were successfully traversed. So these were the observations that I had explained. So this is the ladder diagram without the device in the test, where the call flows between the client and the server. So we have all the components for the successful call establishment. We have the 180 ringings, the STP, the ACK and the BY, the 200 OKs. And this is the ladder diagram with the device in the test, the ESRP. So here the calls were not being established. This is one thing we are working on right now, to establish a complete call flow from the client to the server and the server back to the client. The invites are being forwarded. The ESRP forwards the invite to the server. The server says a 200 OK to the ESRP, but somehow we are getting lost calls in between. So this is one area we are planning to work on. So yeah, as I explained, these are the observations about the ladder diagrams we made. There was a successful call establishment rate, and all the components required for the call was established when the calls flew directly between the client and the server. And when there was a proxy involved, we had a request timeout, and the ESRP was not forwarding the invite to the client. So these are the corresponding Wireshark traces which is captured. This is for the without device under test. And this is with the device under test.
Finally, we'll hear from we do a lot of SIP performance benchmarking, as you can see. So the idea for the next project is, could we do this as a service? In other words, if you have a proxy or a back-to-back user agent and you'd like to test using we actually have some scripts that we can run to get the maximums call establishment rate. So the students will talk about their work on putting the SIP performance testbed into the cloud and in future allowing people to test their devices there. Are you using my? Yeah. Okay. All right. Let me get it.
Hello everyone, I'm Sampada and here's Sriram. Now we are here to talk about SIP performance benchmarking in cloud. Our main project goal was to create a SIP performance benchmarking testbed in the cloud and offer cloud-based service to any SIP proxy or a server. Here, as a proof of concept, we have chosen FreeSwitch as device under test, and we have used SIP tool for generating SIP traffic. And this is just the representation of showing how the testbed is placed in the cloud.
So this semester we have learned about SIP, FreeSwitch tools, and how to register SIP users with FreeSwitch. And finally, we were able to make successful calls between the SIP through the FreeSwitch. We have implemented the whole project in the cloud, and we have used Amazon Web Services for the cloud support. We have used tools like T-Shark, Dropbox, which we used for collecting the traces from the FreeSwitch in the instance in the cloud and get it in the remote devices. So this is the architecture which is up in the cloud. We have 3 instances, 2 of them having SIP devices running in it, and the FreeSwitch proxy. And once when we made the registrations, we were running load tests for finding how many registrations the FreeSwitch can handle between the SIP, from one SIP, as well as finding the maximum call rate between the SIP instances.
These are the load test parameters. R represents the rate of request, and RP is the time interval between the calls, and duration of calls is denoted by D. These can be seen in the scripts which we have used. The first script is used for registration purpose. The SIP devices are registered with the FreeSwitch using the first script, and call establishment is done using the second step, which is shown below. These are the ladder diagram. The first ladder diagram shows registration. The SIP user is registering with the FreeSwitch, and the next ladder diagram shows the call establishment between the registered SIP users.
So the screen here shows a snapshot of the scenario screen when we were running registrations at a rate of 500 registrations per second. So you can see the number of registrations, and this was taken at a random time of 16 seconds, and all the registrations were successfully accepted by the FreeSwitch. So our aim was to find the maximum rate the FreeSwitch can handle for a long time before it starts throwing failures, and we used algorithms from the document 7.5. Sorry, I think we have to.
Is there power here?
Yeah, yes, it's.
Because I'm not connected to.
It's been running for a long time.
Okay, just open it again. I need to connect it to power.
Okay, so back. So basically, we had to find an initial candidate rate for starting our load run, and once we found the rate, we had to do multiple sock tests to see how far the CP can, the free switch can handle the registrations. So at a point of 595 registrations per second, we could find that the free switch is still running strong and getting all the successful registrations. So you can see the number of registrations, 595, and we did this testing for about 3,000 seconds, it's about 55 minutes to 1 hour, and still the free switch was showing no error. So we finalized the value. Because the next one, 596 registrations per second, the free switch started failing at 21st minute. So we finalized 595 as the registration rate the free switch could handle for this instance in cloud. And another interesting feature which we noted was when we was trying to benchmark the number of calls the free switch was trying to make. The free switch is already have a parameter in the configuration file with the maximum sessions. So the free switch is built with the limit to support the maximum number of calls, and any call more than the set of value of 1,000, it just ignores and drops the call. So this was another interesting feature which we noted while we were trying to figure out why there was no calls forwarded when it was more than 1,000. So the basic conclusion.
The conclusion is we have set up a benchmark scheme for free switch, and the registration rate is 595 registrations per second, and we have successfully implemented the default value is 1,000 calls per second. So we have used Amazon EC2 instance, which has T2 micro instance with configuration 1 virtual CPU, and also it has 1 gigabit memory. This is the hardware specification we have used. And here we have successfully proved that with any SIP server or proxy can be used for performing SIP performance benchmarking in cloud, so that anyone in the world can access the cloud, and this can be used as a service in future without any hardware requirements.